All right, we'll go ahead and get started. I'd like to welcome everyone to today's pulmonary critical care and sleep medicine grand rounds. To those of you who were able to come in person and to those many who are online. I'm very pleased and honored to introduce Dr. Meir Kryger today for his Pulmonary Critical Care and Sleep Medicine Grand Rounds Honor Lecture entitled The History of Sleep Medicine, Sleep Science and Medicine. This lecture really honors Meir's 50 years of contributions to sleep science and sleep medicine. I don't think there is anyone more qualified to give this lecture than he is. Meir's contributions to the field started when he was a house staff during his internship and residency with a patient who was admitted to the hospital who was suffering from severe somnolence and nocturnal seizures. And as an intern and resident, he suspected that something abnormal was going on with this patient's physiology at nighttime, managed to jerry-rig some components of a basic sleep study together, and ended up diagnosing and writing up the first case report of obstructive sleep apnea in North America. It was a paper entitled Sleep Deprivation of an Obese Patient, a Problem with Periodic Nocturnal Upper Airway Obstruction. So we knew a lot about Pickwickian syndrome and obesity hypoventilation, but this was the first case report of sleep apnea, and it's only been up from there. He did his pulmonary fellowship training at the University of Colorado and spent the first 30 years of his illustrious career on faculty at the University of Manitoba, where he was the director of the Sleep Disorder Center at St. Boniface Hospital Research Center. He was the founding and senior editor of the Principle and Practice of Sleep Medicine, the preeminent textbook in our field. Now it's in its 7th edition. He's received numerous achievement awards for his contributions to sleep science and to sleep medicine, including the Nathaniel Kleitman Award from the American Academy of Sleep Medicine. Nathaniel Kleitman was a co-discoverer of REM sleep. The Distinguished Achievement Award at the ATS, the National Sleep Foundation Lifetime Achievement Award, the Canadian Sleep Society Distinguished Scientist Award, and multiple other outstanding educator awards. We were very fortunate to recruit Meir to Yale for the last 10 years of his career. And when he came on board, he immediately elevated our academic program in sleep through his clinical excellence, caring for some of our most complicated patients, and his teaching. And it was like sort of having a direct pipeline to all the influential scientists and leaders in the field of sleep medicine. And he brought to us directors of federal agencies, the head of the National Transportation Safety Board, who was a sleep specialist, as well as a Nobel Prize winner who discovered the molecular mechanism of circadian rhythmicity, just to mention a few. Meir has over 350 publications, 29 books, 13 reviews, several software packages that he has put together, including one called The Journey to Sleep, which was actually my first introduction to the field of sleep medicine. And I think as a first today for Yale Pulmonary Critical Care and Sleep Medicine Grand Rounds, Debbie Lovejoy and I have received over 30 requests for the Zoom link to today's lecture from all over the world, including 50 now, Iran and Europe and India. And so much like you have done, Meir, throughout your career, you are now setting new standards even for this lecture series. So welcome back, and the podium is yours.
Thank you.
You're very welcome.
So Clara almost gave my lecture. I mean, it's crazy. So I'm going to be talking about the history of sleep science and medicine. And here's the disclosure. And if you want to get credit, just quickly jot down what's written on this slide. I don't have any conflict of interest for this talk. So here's what I'm going to cover today. I'm going to talk about sleep and dreams through the prism of time. And I'm going to cover 25 centuries in 45 minutes. So I'm going to obviously leave out some stuff and speed through other stuff. And the timeline begins 400 BCE. Now, scientists have always been fascinated with dreams, and this is, of course, Hippocrates, and some of the very early scientists were actually also philosophers, and you'll see that coming up several times. So Hippocrates wrote about the soul. All of the functions of body and soul are performed by the soul during sleep. Whoever therefore knows how to interpret these acts aright knows a great part of wisdom. Now, such dreams as are divine and foretell to cities or to private persons, things evil or things good. In other words, he looked at dreams as something mystical, if you will, and in some cases prophetic. So also, they've not been just interested in the soul and the dream, they've been fascinated with sleep. And this again is Hippocrates, and believe it or not, he wrote a lot about sleep. I have known many persons in sleep groaning and crying out, some in a state of suffocation, some jumping up and fleeing out of doors and deprived of their reason until they awaken, and afterward becoming well and rational as before, although they be pale and weak. And this will happen not once, but frequently. So here he's describing sleep terrors, sleepwalking, and so forth. We'll come back to that a little bit later. So we're going to fast forward now about 100 years to 360 BC, and we're going to go to Crete, to Heraclius, now called Crete. And we're going to talk about Dionysius, who was a tyrant. He was the leader, the dictator, and he was born in 360 BC at the same time as Alexander the Great. And he was described in textbooks as an unusually fat man, which increased to such a degree that he could take no food which was not introduced into his stomach by artificial means. At last, however, he was choked by his own fat. More about Dionysius. So the same historian now writes, so remember, he was an enormously obese individual. When he held audiences with people who desired to see him, he placed a box in front of his body in order that while hiding the other parts of his person, his face alone might project above them as he conversed with his interviewers. In other words, he did not allow his body to be shown. So he had symptoms, and these are beautifully described in history books. He was sleepy, he was difficult to arouse, and he had problems breathing during sleep. And so these, of course, are the symptoms of sleep apnea. And these symptoms were described at the time of Alexander the Great. This guy had doctors, and this is the first treatment of sleep apnea. So the physicians prescribed that he should get some fine needles, exceedingly long, that they thrust through his ribs and belly when he happened to fall into a very deep sleep. Now, up to a certain point under the flesh, completely calloused as it was by fat, the needle caused no sensation, but if the needle went through so as to touch the region which was free of fat, then he would be thoroughly aroused. Okay, so that's not a whole lot different than what is done now with hypoglossal nerve stimulation. So that's just a preview. So one of the things that everybody has observed, including these early philosophers / scientists, was that every living creature sleeps. And Aristotle wrote about this, and here's Aristotle. By the way, this is in the Metropolitan Museum, magnificent work. So Aristotle was also a philosopher / scientist, and he wrote about the soul. He wrote about the soul. With regard to sleep and waking, we must consider what they are, whether they are peculiar to soul or to body or common to both. Further, in addition to these questions, we must also inquire what the dream is and from what cause sleepers sometimes dream and sometimes do not, or whether the truth is that sleepers always dream but do not always remember their dream. And if this occurs, what his explanation is. So there was this fascination with dreams because everybody dreams, everybody has always dreamt. He also wrote about the science, and he wrote about the fact that every creature that's out there sleeps. And he wrote, accordingly, almost all other animals are clearly observed to partake in sleep, whether they are aquatic, aerial, or terrestrial, since fishes of all kinds and mollusks, as well as others which have eyes, have been seen sleeping. So this again was the dichotomy of sleep and there was a mystical element, thinking about the soul, and the scientific element as well. So one of the things that is great about Yale is the professors that you encounter and the people that you encounter in fields outside of your own. So when one of my friends, who is an Italian professor, heard a few years ago that I was giving a talk about sleep and dreams and so forth, she said, "Have I heard about the dream of Scipio, what Macrobius wrote about dreams and what Chaucer wrote about dreams?" And I said, I didn't know anything about what she was talking about. So, so I went and did some work here. And there were people who wrote about dreams and the interpretation of dreams a long time ago. And Cicero in 54 BC wrote about what has been called the dream of Scipio. Scipio was the general who defeated Hannibal. He falls asleep after a battle, and he's visited in a dream by his grandfather. And his grandfather was also a general, but was dead. And the two of them went up into the universe and they looked around and then they came back. And so this was called the dream of Scipio. And it became, for reasons that aren't clear to me yet, it became an incredibly well-known story. So this again is in the National Gallery in London. It's like a jewel, this painting, and it shows Scipio sleeping here. So there's more. So Macrobius was a philosopher who wrote a commentary about about the dream of Scipio. And in the commentary, he describes 5 different types of dreams. One of them is called somnium, an enigmatic dream that requires interpretation. As soon as you think of that, Freud sort of instantly comes to mind. He then describes a visio, a prophetic vision that comes true. And what do we think about there? The story of Jacob in the Bible, where he has a vision about his people occupying a certain land. Oraculum, a prophetic dream mediated by authority. And this is the story of Joan of Arc. Joan of Arc, she had saints visiting her during a hallucinatory state or a dreamlike state, and told her about the future, about what was going to happen with a battle with the British. Insomnium, a nightmare or false or misleading dream caused by bodily disturbance, post-traumatic stress disorder. And then visum, a nightmare with supernatural contact or an apparition. And of course, you immediately start thinking about Charles Dickens and Christmas Carol. That entire story fits into this definition. So we're going to fast forward now 1,000 years. And Shakespeare describes sleepwalking in Macbeth. Now, if those of you who have read or have seen Macbeth, that play is full of abnormal sleep stuff. And this is just one example. Since His Majesty went into the field, have seen her rise from her bed, throw her nightgown upon her, unlock her closet, take forth paper, fold it, write upon it, afterwards seal it, and again return to bed, yet all this while in a most fast sleep. Beautiful description, and there are several other descriptions in that play that are just phenomenal. Cervantes in Don Quixote, he described REM sleep behavior disorder, rapid eye movement sleep behavior disorder. Beautiful description. In his right hand, he held his unsheathed sword with which he was slashing about on all sides, uttering exclamations as if he were actually fighting some giant. And the best of it was his eyes were not open, for he was fast asleep and dreaming that he was doing battle with the giant. So about 100 years after that, Jean-Jacques Desmarins described circadian rhythm in plants. He showed in an ingenious experiment that a plant was actually able to keep track of time, and its leaves would open around the time when the sun was sort of at its peak during the day. And it didn't matter whether the plant was in a box exposed to sun or not. A simple but brilliant experiment. 1818, John Chain, a case of apoplexy in which the fleshy part of the heart was converted into fat. This is a breathing pattern which we recognize today in patients that have heart failure. For several days, his breathing was irregular. It would entirely cease for a quarter of a minute, then it would become perceptible, though very low. Then by degrees, it became heaving and quick, and then it would gradually cease again. This revolution in the state of his breathing occupied about a minute, during which there were about 30 acts of respiration. We're going to fast forward now 20 years to England. Charles Dickens, barely 20 years old, publishes his first novel, The Posthumous Papers of the Pickwick Club, 1836. And in this book, he describes sleep apnea. He doesn't describe it on Mr. Pickwick, who's shown here chasing after his hat. He actually describes it in Joe the Fat Boy. And that's the only description of this character in the book. He doesn't have a surname. He's just called Joe the Fat Boy. And Dickens introduces us to him, and on the box sat a fat and red-faced boy in a state of somnolency. How does Dickens describe Joe? 20 stun. A stone is 14 pounds, so he's immensely overweight. And this is a play on the word stone and ton. He's red-faced, he's plethoric, something that we recognize in many patients who have a high hematocrit, and he's described as being a young dropsy. Dropsy is the old term for edema, for peripheral edema. He's also difficult to arouse. The fat boy rose, opened his eyes, swallowed a huge piece of pie he had been in the act of masticating when he last fell asleep. In response to the firing of enormous guns at a military exercise, everybody was excited except the fat boy, who slept as soundly as if the roaring of cannon were his ordinary lullaby. He snored. Joe snores as he waits at the table, and the snoring of the fat boy penetrated in a low, monotonous sound from the distant kitchen. I wonder if that's me. Uh-oh, hang on. All right, so I better turn that off. That was my sister. It was her birthday yesterday. Anyways, I did wish her a happy birthday. So, oh God, anyways. I'm gonna turn this off here. Hang on a second here. All right. So that's right. That would be cool, right? So here we are in 1836, and what were scientists thinking at the time? What were doctors thinking at the time about sleep? The conventional wisdom was that sleep was a form of reversible death. Reversible death. And so not much had changed in like 2,000 years in thinking. So when we go back to Aristotle, Aristotle wrote about where sleep kind of resides in the body. And this is what he wrote: the organ in which sleep and waking originate is self-evident. And this is in a book that he wrote called Of Sleep and Sleeplessness. And he thought that sleep occurred in the heart. And the heart was where your soul was, and this is where your dreams were. Okay, the organ in which sleep and waking originate is self-evident in the heart. So not much had changed in 2,000 years. So philosophers and scientists, how did we get to the point where we have an understanding of what happens during sleep? So it had been known for thousands of years that some sea creatures could produce shocks. It was also known that if you rub two items together, that you can create electricity. So the idea of currents had, it was known, but not much changed until this guy. And this guy is Benjamin Franklin, and some of you might have been lucky enough to have him in your pocket. So he did an experiment in 1752, which was written up in 1774, where he talked about electricity. And there was very little written about electricity, but it was important to know about electricity because, oh, by the way, this picture here is Benjamin Franklin signing the Declaration of Independence. This is in the museum, the Yale Art Gallery, by John Trumbull, who was probably the most famous revolutionary painter. So science advanced. In 1791, Luigi Galvani showed that nerve cells can produce electricity. Alessandro Volta showed that cells were like batteries, that they could actually capture energy. Helmholtz in 1849 showed that nerve cells can conduct, and he was able to measure the conduction of nerve cells. Golgi developed staining techniques showing the individual neurons of the brain, and this was elaborated in 1887, which showed that the brain was made up of networks, and that yielded a Nobel Prize. So up to that point, it wasn't yet known about animal brains yet, that they had electricity. They knew about cells, but they didn't know about brains. So Richard Catton, who was an Englishman, actually documented that brains have electrical activity. And he did this in 1875, and it was in the proceedings of the British Medical Association. And this was a very brief report, but it was earth-shattering. After a brief resume of previous investigations, the author gave an account of his own experiments on the brains of the rabbit and monkey. The following is a brief summary of the principal results. In every brain hitherto examined, the galvanometer has indicated the existence of electric currents. And that was critical. That was a critical development. So in the 1870s, psychiatry and neurology were intertwined. That was a period of tremendous growth. In the 1870s, the first comprehensive textbook of neurology, Leçons sur les maladies du système nerveux, was published in 1877 by Charcot. That same year, Sigmund Freud started to compare brains from different animals. He did not graduate from medical school until 1881. A lot of people don't realize what his background was. He was initially, a hardball scientist. All sorts of neurological diseases were discovered and described by brilliant clinicians, and the discoveries were often presented simply as presentations to medical societies and then published in journals. So the very first clinical description of a sleep disorder was that of narcolepsy. And it was two people who 3 years apart described the main symptoms of narcolepsy. In those days, you had to have 4 names in order to become famous. So Westphal described cataplexy simply as a presentation to the Berlin Medical and Psychological Society. And Gélineau described sleepiness in a wonderful journal called the Gazette of the Civil and Military Hospitals of the Ottoman Empire. And I did not make that up. So a few years later, in the 1890s, Ivan Pavlov did his really famous research on conditioned reflexes. And this became the basis of the psychological treatment of insomnia 80 years later. Sigmund Freud, okay, in 1900, he wrote The Interpretation of Dreams, and which had a tremendous impact on psychiatry. So his thesis was that dreams have two meanings. If you dream about something, it has two different kinds of meanings. One of them is what has been called the manifest content, their apparent meaning. So for example, when you look at this painting by Magritte, I don't know if you know French or not, but it says, "Ceci n'est pas une pipe." This is not a pipe. And that was like a play on words because this is a painting, because this is a painting. So that's the manifest content. The latent content is the hidden real meaning of the dream, or is it? So, so he wrote books on the interpretation of dreams, and this became an important aspect in psychoanalysis. So in his idea, the dream actually has a secret meaning, which turns out to be the fulfillment of a wish. King and queen in most cases really represent the parents of the dreamer. The dreamer himself or herself is the prince or princess. All elongated objects, sticks, tree trunks, and umbrellas might be compared to an erection. Staircases, ladders, and flights of stairs, or climbing on these upwards or downwards, are symbolic representations of the sexual act. In other words, his idea was if you dreamt something, it meant something else. And that actually was not that new in terms of thinking, because the Egyptians 3,000 years before actually had a book of the interpretation of dreams, but he had tremendous influence. So Albert Einstein describes relativity in 1905, and you're probably, which changed the concept of time and space. Why is this important for sleep? Tune in to 1938, where I'm going to elaborate on this. So in 1905, he describes relativity. In 1929, Hans Berger shows that the human brain has electrical activity that you can record from the scalp. And that was brand new. That had not ever been done before. So W.R. Hess, who was a Swiss physiologist, stimulated the posterior hypothalamus, which was able to induce sleep in animals. And until then, science had no clue that there were centers that can induce sleep. He won the Nobel Prize years later, because his research was in the 1930s, so it took almost 20 years for him to get the Nobel Prize. That same year that he got the Nobel Prize, Maruzzi and McGowan described the reticular activating system, the arousal system of the brain. They did not get a Nobel Prize. They should have, but they did not. Alfred Loomis in 1935 describes the EEG of sleep. And now whenever we do a sleep study, we record the EEG, and this was the first time that somebody actually did something like that. 1937, Annie Spitz, who was a Czechoslovakian neurologist, in a really terrific paper, described 3 people who had low blood oxygen, sleepiness, and heart failure. And she thought that this was somehow a combination of narcolepsy and a polycythemia. And what we now know is that she was probably describing sleep apnea. She kind of vanished during the war. She was Jewish, and she vanished for a few years, showed up after the war in Sweden. So, and this is actually a photograph taken from her paper. And when I first saw this paper and I saw that this is the kind of person we see in our clinics every single day. So I mentioned Freud, and now I'm going to talk about Salvador Dali. So Freud and Salvador Dali met in London on July the 19th, 1938, and this was only about 2 or 3 months before Freud died. And that picture on your right is actually a picture that Dali did of Freud at that meeting. Why were they meeting? They were meeting because he was Freud was one of Salvador Dali's heroes. And Salvador Dali was not, there was a lot of controversy around his life. As you know, he was a surrealist painter, and he was accused by other very prominent painters of being an anti-Semite. And the person who accused him was another, in fact, the person that wrote the book, the Surrealist Manifesto, a guy by the name of Andre Breton. So this is actually something that Freud wrote. He said, how can I, this is a false accusation. The two people that had the greatest effect and influenced me the most in my life were Semites, were Jews, Freud and Einstein. And he was a lousy speller. He was a lousy speller because he got both of their names wrong. So what was important was surrealism, and the paintings that Dali did were really dreams. They were really dreams. And this is his most famous painting, which shows the warping of time. And basically, almost all of his work shows a distortion of time and space and hidden meanings. In other words, when you look at one of Dali's paintings, you never really, it's never obvious. You always have to think about what he's actually showing. So dreams and sleep, and in fact, he even did some paintings of his wife Gala asleep. So the question is now, so now we're in the 1940s, early 1950s. What is happening in the brain during a dream? Where's the mind? Where are the dreams? And what starts dreams? So we're going to go to 1953. That was a very good year for science. In April of 1953, Watson and Crick described DNA. Literally and they of course got Nobel Prize. 3 or 4 months later, Aserinsky and Kleitman described rapid eye movement sleep. Had it not been for the fact that DNA was described that year, they would have gotten the Nobel Prize, I am sure. So this is Kleitman, and this is a photograph that I took of him. He was 100 years old, and he had just given a lecture on the discovery of rapid eye movement sleep. This was in Nashville, I think it was 1995. And at the time I was a young kid, and there I am holding his book. He had written a book about the physiology of sleep, and he died shortly after. So we're now going to go to 1956, a very famous case report. The patient was accustomed to playing poker once a week. And on this crucial occasion, he was dealt a hand of 3 aces and 2 kings, a full house. Because he dropped off to sleep, he failed to take advantage of the opportunity, and he went to seek medical help. And they decided that he had a new syndrome, And the syndrome was the Pickwickian syndrome, and it was named in the honor of the Pickwick Papers. So this was the stereotypic obese patient, that has been described: male, middle-aged, in right heart failure, has a very high red cell count. So about 10 years after that, 3 European groups actually started to do sleep studies in patients with the Pickwickian syndrome. In other words, patients that had awake hypoventilation. What they found, there was obstructive apnea, low blood oxygen levels, high blood pressure, and awake hypoventilation. And it was thought to be exquisitely rare, exquisitely rare. 1970, Bill Dement starts the world's first sleep clinic at Stanford. And very soon after this, he started to teach a course at Stanford called Sleep and Dreams. It's the most popular course at Stanford ever. And every famous person who's ever gone to Stanford has taken this course. It's just amazing. So the 1970s was really a golden age of sleep research. In 1971, there was a description of flies with a mutant gene that affected their circadian rhythm. In 1972, the location of a circadian clock in humans in the suprachiasmatic nucleus. 1974, obstructive apnea is described, differentiating that concept from Pickwickian syndrome. 1976, it was found that melatonin can alter the circadian rhythm. This is now 1974. So 1974 was a good year for me. This is my wedding. And it was also the start of my sleep medicine career. It started with a case that Clara had really talked about. And the important thing about this case was that it didn't fit the medical literature, So as Clara mentioned, I had a friend who was a neurosurgery resident, and we put together a circuit and we measured a bunch of things and there was no oximeter at the time. There was no oximeter that could record continuously, but we were able to record movements. We were able to record the EEG. And basically, we found the patient, as Clara mentioned, came in with seizures. And the reason he was having the seizures were that his heart stopped. And it would and this is when he was making efforts to breathe, his heart would stop, and that was the explanation for the seizures. And the first treatment was putting a hole in his windpipe, a tracheostomy. And I remember going to my attending physician at the time, and I said, we need to do a tracheostomy here because I don't know what else to do. And he said, go ahead. So the sleepiness resolved literally in one night, never had another seizure, no arrhythmias, and he was in essence cured, except he had a tracheostomy. So this was my first paper, which was published about 4 months before my wedding. So the 1980s was really a golden age of sleep medicine. There were clinics established everywhere. CPAP was described by Colin Sullivan in 1981. All sorts of disorders were defined, and here's the first textbook that I worked on with Tom Roth and Bill Dement. And as Clara mentioned, this was the first edition, and the last edition, that was 1989. The last one just came out, the 7th last year. There were all sorts of major discoveries. Clock genes in 1984. The fact that light can reset circadian rhythm, 1986. 1993 was the first article that showed that sleep apnea was a public health problem because it affected a minimum of 4% of males and 2% of females. We now know the number is much greater. 1999, orexin's role in narcolepsy was described, and a sleep switch was described in 2001. So in 2017, the Nobel Prize in Medicine or Physiology was for the discovery of clock genes in fruit flies. And these are the three people who shared the Nobel Prize. The guy in the middle is Michael Rosbash. And during COVID, in November of 2021, exactly 2 years ago, almost to the day, he came to teach at the course that I do for undergraduate students at Yale. And here he is wearing a mask. And you know, what a great thing it is to have students exposed to a Nobel Prize winner. And we then had a meal at the Schwarzman Center. It was completely empty except for us. This was in the middle of COVID. And we were in this gigantic space and we were the only people in that space. Then we had a second golden age. And the second golden age is what we're in right now. So what we now know is that every form of life, from a bacteria, plant and animal cells, eggs, you name it, everything that has life have clock genes. They have periods where they rest and periods when they are active. They all have clock genes. And one of the things that's sort of amazing is that our planet is inhabited by all sorts of different forms of life. And there's a huge amount of fascinating research looking at how sleep has adapted in all these various species. And I can't go into a huge amount of detail here, and I'll just give you a couple of examples. Fascinating research. For example, does diet matter? So in herbivores, the elephant only sleeps 2 or 3 hours out of 24. Why? Because the elephant is gigantic. What does the elephant eat? The elephant eats very low caloric food, leaves, grasses, and so forth. So the elephant has, in order to stay alive, has to spend like 22 hours a day foraging for food. That is an example of the type of research that is going on right now. So also, it's not just the number of hours of sleep that's important, and we're learning a lot. The amount of the different stages of sleep varies like crazy. So for example, if we look at the amount of rapid eye movement sleep in different creatures, here's just 2 examples. The platypus has 8 hours of rapid eye movement sleep out of 24 hours, spends 1/3 of its life in rapid eye movement sleep. On the right side, the bottlenose dolphin has 0 REM sleep, and the dolphin and a lot of marine mammals have evolved in such a way that only part of their brain is asleep at any given time, and so that they are always awake, at least part of their brain is awake 100% of the time. So this type of work is just fascinating. So in terms of why is sleep important, one of the things that we think is going to be critically important is this, is the purpose of sleep to allow for the cleaning the brain of waste materials. The answer is yes. So in 2012, the glymphatic system is described, and many of you here probably have never heard about it. This is probably going to be a future Nobel Prize. So why is this important? This is important because neurons produce waste. And there's this new system that has been described, they use the term glymphatics. They remove the waste. And it turns out that these glymphatics are the most efficient during sleep, okay? The most efficient during sleep. So chronic sleep deprivation, because it will result in decreased lymphatic flow, is going to result in an accumulation of stuff, junk, that will accumulate in the brain. You add to that genetic risk factors, and you add to that aging, And what you then have is neurodegeneration, cognitive decline diseases. And then these diseases in turn result in sleep deprivation, poor sleep quality, and we're stuck in a vicious circle here. So this accumulation of pathology is really, really important. And the glymphatic system is what's important in getting rid of that junk. So the toxic proteins accumulate in the brain. We have amyloid beta, which accumulates in Alzheimer's, tau, which accumulates in Alzheimer's, chronic traumatic encephalopathy, dementia. CTE is what football players get ultimately if they've had a lot of head trauma. And then alpha-synuclein for Parkinson's disease and Lewy body dementia. All of these are impacted by sleep deprivation, and all of these diseases in turn reduce the amount of sleep. So these patients are frequently stuck in a vicious circle. So we're sort of towards the end of our story here. And so we know, we know that sleep is everywhere. I mean, it's all over the media, it's all over everything. There's books, magazines, and so forth. And we know that sleep affects personal health, well-being, performance, diseases. There's an obsession with wearables right now. It affects transportation. It's important to think about sleep when avoiding disasters, be it a locomotive engineer or a surgeon doing an operation. So I want to circle back to Aristotle, and I want to emphasize again something important that he wrote that I've already mentioned. Accordingly, almost all other animals are clearly observed to partake in sleep, whether they are aquatic, aerial, or terrestrial, and so forth. In other words, everything that's alive has periods of rest and activity. Which brings us to this. So basically, all forms of life on Earth sleep and rest. And this is a quote from Alan Rechtschaffen, who died a couple of years ago. If sleep doesn't serve an absolutely vital function, it is the biggest mistake evolution ever made. Thank you.
Meir, thank you so much. We're going to open it up for questions. And I think you took us through this great big picture view of the science of sleep. I think clinically, I think we all in the field got a boost this year when the American Heart Association sort of recognized sleep health as one of life's essential 8 now. And because of some of the strong linkages with cardiovascular health, et cetera. And you alluded to, I think, sort of where things are moving in terms of sleep science, the glymphatic system, circadian biology. I'm curious where do you think clinically the field of sleep medicine is moving, given your perspective on the field? What do you think we'll be doing, moving? What we'll be tackling? What are better ways that we may be able to be?
So if you think in terms of the neurodegenerative diseases, we don't get a whole lot of referrals from that group. And I would not be surprised with that within a few years, there will be treatments that will involve sleep, that the glymphatics will open up and the junk will be removed. And we might be able to treat some of these terrible diseases. I think we're going to see a lot more of them. I think we're going to be seeing many, many patients who have, for example, COPD, heart failure, and so forth. And we're going to get better at dealing with their sleep problems because they all have sleep problems. And again, we're not getting that group of patients enough. So I think that's where that aspect of the field is going to go. I think the circadian world is going to explode as well. For example, drugs. when we think in terms of drugs, is there an ideal time to give a drug? In terms of that patient's circadian rhythm. So it's quite possible that in 10, 15 years, when we're going to be prescribing drugs, be they chemotherapeutic agents or antibiotics, we're going to know about that patient's circadian rhythm and when to give them the actual drug. So I think the field has a lot of really exciting things that are going to happen.
Mayor, thank you. It's an enormous honor to be a colleague. One of the striking themes, I think, of your career that also goes throughout your talk today is the notion of paying attention to the things that you're seeing. And I think one of the extraordinary observations was that sleep apnea was thought to be rare. And despite that, you as a young trainee, picked up on the fact that there's this incredibly important disease. And now you fast forward to 2023, I can round with my residents in the MICU and go to all number of beds and say, watch this patient sleep, watch this patient sleep. And there's one sleep apnea patient after another. So how is it that something that was right there in front of everybody's noses was ignored or not seen? And what do you think the important lesson is there, that you were actually able to see this?
Yeah, I can't remember who said this, but some famous philosopher said, you only see what you know. And in other words, if you don't know what you're looking for, you're not going to see it, even though it can be right in front of you. And I've always been going in to see patients. And the patient that I described, I remember going into his room at night, watching him struggle to breathe. And I remember thinking, I don't know anything about this. This guy's got something I don't understand or know. And so, the stuff that I did, you can't do today. In other words, if you're in the hospital and somebody makes a finding, they can't like jigger up a system and start measuring stuff because it just doesn't happen anymore. And one of the things that to me is a little bit troubling is that there's a decrease in the interaction between doctors and patients. They spend way more time in front of the computer than they do with their patients. And I don't know how that can change. You can't make observations unless you observe, and you're not going to observe much when you're looking at a computer screen.
Hi. First of all, thank you for the lecture. It was really interesting. One thing I'm kind of curious about is that we know that sleep is very vital, right? But like knowing that it's so important for our normal function, why is there so much variation among individuals, right? Some people can survive on 5 hours of sleep and with no impact on their cognition or lifespan, but other individuals need like 8 to 9 hours of sleep. So it plays a role in cleaning up our brain from the waste material and stuff. Why is there so much variation among individuals?
Well, there is a lot of variability. There's a lot of variability in the ideal amount of sleep that a given individual needs, just like there's a variability in shoe size, just like there's a variability in hair color. In other words, it's a trait that we've probably inherited. And we don't know yet how that actually happened. But there is a lot of variability. There are some people that appear to get along well on 4 hours of sleep. I wouldn't want them to be the pilot of my airplane that I'm flying anywhere, but they claim that they can do well. I can tell you that the Department of Defense has been looking for years to try to find people who would become warriors who don't need to sleep at all. And this is the thinking, but the reality is most people need to sleep, and they need to sleep between 7 to 9 hours. There are outliers. I mean, if you look at very famous athletes, LeBron James sleeps 12 hours a day. A lot of athletes sleep a lot, and they apparently need it. They know their body so well that they know how much sleep they actually need. And you know how much sleep you actually need. Even if you lose 15 minutes or 30 minutes, you're gonna feel that.
Thanks so much again. I have a question about your opinion on the future of technology, particularly with wearable devices. I think a lot of us are seeing patients who come in and say, my Apple Watch tells me that I have sleep apnea. And I just wonder, as someone who started out with a neurosurgeon friend, just throwing electrodes on people, what do you think the future holds in terms of wearable technology as it informs our sleep practice?
I mean, the whole wearable technology space is fascinating. And the important thing is that some of the wearables, there's no biologic plausibility for what they are doing. In other words, there's no way that we know of right now that you're going to put a cell phone somewhere in the patient's room and it's going to tell you whether you're dreaming or not. It might be able to tell you whether you're breathing or not because of physics and the movement of molecules that you can detect. But there's a huge amount of research going on right now in the wearable space. The FDA does not have good guidelines on the medical use of wearables. The Apple Watch, the only FDA clearance that it has is for the detection of atrial fibrillation. That's it. Okay, and it's very good at that, by the way.
Another question up here, then we're going to go to the chat. Yes. We have more questions? Go ahead.
Yes, apologies, I'll be brief. Hello, hi. As someone who was particularly guilty of staring at their phone for quite a while before going to sleep, I was wondering, do you have any thoughts on what we can do to sort of combat this kind of encroaching intrusion of like electronics technologies that involve artificial lighting, things that sort of kind of creep in on the entire sort of more natural day-night cycle that we've been living through for hundreds of years up to now? Like, because it seems like the nights are getting brighter and it just seems like there's more lights just everywhere, even within sort of the interiors of where we work, where we live. So it's like, I guess, is there anything sort of that we can do to try and still fight back against this?
You can turn off the electronics. and I'm serious. I am serious. I am serious because when you look at a screen, it is stimulating receptors in your eyes that are sending signals to your suprachiasmatic nucleus, and they're going to affect your circadian rhythm. And so you can get blockers that'll sort of get rid of the bad wavelengths. There are things that you can do, but the first thing you need to do is to make your sleep a priority and say, I'm not going to waste my time on TikTok or Instagram or whatever. And it's a personal decision that every individual needs to make. How much time am I going to spend doing something which I probably don't need to do?
I'm going to pass the phone to Dr. Langston, but before I do so, I just want to announce that she and Dr. Murphy, who asked the previous question, we found out matched in our sleep medicine fellowship program today. Oh, welcome.
So I was just wondering about now that, sleep disorders are sort of taking more of a national forefront, like getting involved at a public health level. Like, is there thoughts that, AASM, which is a pretty young organization, I mean, the sleep board itself is quite young, like moving over into more of a public health role? Like, do you have thoughts on that? Because you've seen the field really evolve.
Well, yeah, I mean, and the field has evolved in a lot of different directions. I mean, if you look at, for example, the transportation industry, there's a whole science that deals with transportation, reaction time, performance as a function of sleep and so forth. And right now, sleep is still a very, very young field. And the field is so young that people like you can find a niche and direct something that you might find really, really very interesting and useful. So I think this is a great time. You're going to be a sleep fellow next year. You're going to learn everything that you need to know, and then you're going to spend the rest of your life learning more. So cheer up.
All right, we're going to just finish off with one or two questions from the chat. And the first one is a very important topic. It's from Brendan Duffy, who asks, how do we convince schools to start healthy sleep lifestyles via healthy school start times?
I would say move to Canada.
All right.
I mean, there's an obsession in the US, in many parts of the country, for high schools to start at 7 o'clock in the morning, ignoring the change in circadian rhythm of teenagers who all have a delayed sleep phase. So the teenagers go to bed at 1 or 2 o'clock in the morning. In order to get to a 7 o'clock class, they need to get up at 5. Their sleep deprived parent is going to prepare lunch. It's crazy. It is absolutely crazy. There have been some success stories in California. There's been some success in Minnesota, and there's some school districts in Connecticut that have done okay. But this is something that needs to change, and there are a lot of interesting aspects to that question.
I'm just gonna go ahead, Naftali. Were you gonna? Actually, if you want to finish, that's okay. The Schwartzman reception. Yeah, I'll make sure and do that. Just because we have over 100 people on the chat right now, and one of whom is a friend and colleague of yours, Dr. Sonia Ankoli Israel from California. Wanted to thank you again for the wonderful educational, entertaining talk. And she wanted you to comment if you are aware of any references in the Bible to sleep. Are any quotes in the?
Oh, there are a lot of quotes in the Bible about sleep. You know, the story of Joseph and so forth.
Yes.
And
You alluded
Sonia,
to,
yeah, I alluded to them. And Sonia has actually written articles about it.
Yes.
And they're fascinating.
Great. All right. Well, I think to Naftali's point, we're going to continue this celebration at the Schwartzman Center from 5 to 7 o'clock. And I think many of us have RSVP'd to join you, and we're very much looking forward. Mayor, thank you for an outstanding presentation.
Thank you.